Hi, I'm Randy Becker with Keysight Technologies. We're here in Denver at IMS 2022. Today I'm going to give you a quick overview of our latest vector signal generator and spectrum analyzer. The new vector signal generator is a high-precision millimeter wave metrology grade instrument capable of the world's best signal purity and quality. It's based on a direct digital synthesis architecture which gives you unrivaled signal generation capability. And I'll give you an example of that in just a moment. These generators come in one channel, which this is a one channel model, but you can get them in 1, 2, and 4 channel models, frequency coverage all the way to 54 gigahertz, and remote millimeter wave heads to take that from 54 all the way to 110 gigahertz. Now what I'm going to do in this first demo is I'm going to generate a multi-tone signal, which you see on the UXA, and this pretty much gives you the ideal looking spectrum. I've also removed one of the tones so you can see what it looks like in the notch. Now I'm going to compare and contrast that with how every other vector signal generator does this today using an IQ modulator. If you look here on the screen is that same measurement made on a generator with the IQ modulator, and because we have the multi-tones offset slightly in frequency, we can see the images that result from the imperfections in the IQ modulator. We can never get them perfectly balanced in every possible way. The IQ offsets, quadrature, etc. That results in these highly undesirable images and a high amount of LO feed-through. This hinders your ability to get the best possible performance. I think you can clearly see the difference between this spectrum on top compared to the spectrum on the UXA. This is so much cleaner and gives you basically the theoretical perfect signal creation capability. Next, I'm going to show you how you can use some of that spectrum in a real-world environment. So I'm going to recall quickly here a different configuration. What we'll see on the display now is several different signals that I'm generating. If we start here on the far left, we have Edge and GSM separated by 1 megahertz, which really looks like a CW tone because we're utilizing the full 2.5 gigahertz bandwidth of the generator. This is followed by wideband CDMA, which we thought was really wide back in the day with a 5 megahertz channel spacing. Then we have 20 megahertz LTE, 100, 200, 400 megahertz new radio, and finally an 160 megahertz 802.11ac signal. Now because of the real-time processing that we're doing, we're able to do this waveform combining in real time. I can give any of these signals different attributes. As an example, I can quickly set and say I want to move one of the carriers to a different frequency. I've now moved the 802.11ac signal from the far right over here to the far left in just the blink of an eye. Now I'm going to show you a couple of other things quickly. We can also add AWGN to the profile. So now I've added noise over a gigahertz bandwidth and give it a small frequency offset just to show some of the flexibility. And then finally, we also have fading built into the solution. So I'm going to go ahead and turn on the fading. And I've only applied it to this middle carrier over here, the 100 megahertz new radio signal, but I could do that to any or all of the carriers of my choosing. In the multi-channel models, that enables things like spatial MIMO fading with the spatial multiplexing. There's a bunch of other features that I'm not going to talk about, but if you want to learn more about those, go to keysight.com. Thanks for watching.